For the quantitative risk assessment of this project, the selected production that will be studying involved in the iron and steel industry, which is the blast furnace. Location of the plant is located at the southwest of Ipoh, nearby residential area, which is Soi Cheong Kilang Besi. The population of the residential area nearby are totaling up to 33,680 population, represented by 3 areas marked by the white dotted lines. The process involved in the blast furnace can be seen here. In summary, the reactants are iron ore, coke and air, while the products of the reaction are melted iron, slag and blast furnace gas. The blast furnace facilitates 4 different chemical reactions as shown. The blast furnace operates at 12,000 degrees Celsius of temperature and at 250 kilopascal of pressure. Where the data of the surrounding found were 28 degrees Celsius for ambient temperature, 84% relative humidity, 4 km per hour of wind speed and Class D weather. The hazardous material that will be studied is the blast furnace gas, or called as BF gas, consisting of nitrogen gas, carbon monoxide, carbon dioxide and hydrogen gas.
Hello, I am Nurin Faqihah and now I'll be presenting on the hazard and operability study of the selected equipment in the steel manufacturing industry, which is blast furnace. The first parameter is temperature. Higher temperature than normal is caused by excess heating, which will be able to cause fire and explosion of the blast furnace. Moreover, the reaction in the furnace will be unbalanced and cause the materials to be wasted. The action towards this deviation is by practicing controlled water for burden cooling and meticulous checking of the hydrogen content in the gas. Next, for the deviation of lower temperature than normal, the cause is due to chilling of blast furnace that would make normal steam making of the blast furnace be impossible. Also, the hot metals will begin to solidify. To prevent this, the furnace should be run on the hottest side by increasing the coke in the charge. The second parameter is pressure. Higher pressure than normal is caused by pipeline rupture, which will cause the carbon monoxide poisoning in atmosphere. On the other hand, lower pressure than normal is due to prolonged heavy hanging, which can blow down the furnace to Bosch level and fill it with coke blank. The action for this deviation is by installing pressure detector. Last but not least is corrosion. Corrosion of blast furnace pipeline is due to the presence of chlorine such as hydrochloric acid during the process that can cause gas leakage. Installing corrosion resistant materials and regular inspection and repair are the action for this deviation.
The scenario that will be studied are line rupture and catastrophic rupture of the blast furnace. The hazard classification of BF gas was divided into 4, which is hazard if inhaled, may damage fertility of the unborn child, causes damage to lungs, may displace oxygen and cause rapid suffocation. For the short pipe scenario, the BF gas discharge will affect a part of the nearby residents in the circle. The downwind will disperse the BF gas leak to the other part of the processing plant, affecting most of the workers. The discharge having flow rate of 1.048 kg per second, velocity of 467 meter per second, and being discharged for 3,600 seconds until the end of the release. Aside from toxic substance release, jet fire and flash fire also occurs when there is an ignition source. For flash fire, the flame length will be 12.4 meter from the source, while the flash fire are having 5.3 meter for the maximum flash distance, with height of 1 meter. Next, for the catastrophic rupture, the result shows the blast overpressure due to the explosion. The red, green and blue line represents different overpressure magnitude, which undoubtedly affecting all 3 residential areas. The overpressure magnitude for red, green and blue line are 0.2068 bar, 0.1379 bar, and 0.02068 bar respectively. From the table, the area in the red line will suffer from steel frame building distortion from its foundation, self-framing steel panel building demolished, and rupture of oil storage tanks. In the green line, there will be partial collapse of the walls and roofs of the house, while concrete or cinder block walls will shatter. The area in the blue line will suffer from broken glass, damage to ceilings, and projectile from the explosions. Fireball will also occur with a diameter of 202 meters, while level 1 and level 2 intensities will be experienced at 202 meters and 90 meters respectively. The flash fire will have maximum distance of 47 meters with height of 12 meters.
Now let's move on to the next part, which is the potential incident frequencies. Line rupture and catastrophic rupture can result in jet fires, flash fires, vapor cloud explosions, as well as toxic release of gas. By assuming that the blast furnace has the similar potential incident frequencies as the BFG line, the frequencies of the potential incidents for the ruptures are shown in the table below. Next, from the graph of concentration against time, it has been obtained that the maximum concentration of BFG release due to the line rupture is 750 ppm. Meanwhile, for catastrophic rupture, the maximum concentration of BFG release is 4650 ppm. To construct a fault tree analysis, the causative factors of line rupture and catastrophic rupture accident and its probabilities were extracted from an analysis that were made based on 50 cases in China. The parent node T was set as the accidents caused, which are the ruptures, while the intermediate nodes are the upper classifications of the root nodes. The data provided was then translated into the form of FTE, where the probabilities of each causative factor occurring in the whole sample were calculated as follows. Based on reference, the unsafe operation of blast furnace can lead to overpressure. By referring to the FTA, overpressure can be due to valve failure, improper gas safety operation, or blast furnace body failure. The use of OR gate indicates that the resulting ruptures require the occurrence of any of the causes. Preceding the causative factors of overpressure mentioned just now are the causes of failures respectively. Apart from that, unsafe behavior, unsafe command, and unsafe condition of blast furnace have also given rise to the ruptures. The extension of the FTA for the other factors are as follows.
Greetings, my name is Imran Mansor and I will be explaining on the risk assessment part. As for the individual risk assessment, 3 locations were observed in the risk ranking points, which are the process plant area, the office area, and the residential area. Based on the results obtained from the safety simulation, it is observed that the process plant area exhibit the highest risk, which are followed by the office area, and lastly, the residential area possessed the lowest risk as it was located the furthest away from the plant. Overall, there are 2 major contributors towards the risk in the Yeocheong Steel Factory, specifically catastrophic rupture in the blast furnace with 99.93 risk percentage, followed by rupture in short pipeline with 0.07% risk percentage. To add on, it can be noted that the potential risk from these 3 areas has exceeded the acceptable region, which is very dangerous. Next, I will be discussing on the location-specific individual risk, in which the aim was to estimate a hypothetical individual's risk exposure at a specified location. According to the simulation results obtained, it is observed that the flammable risk contours span the whole process plant area. However, it should be noted that the office and residential areas will not be affected during the catastrophic events. If we compare to the DOE risk acceptance criteria, it can be summarized that the flammable consequences from Yeocheong Steel Factory is unacceptable as it exceeds the regulated amount. Moving on to the FN curve, it can be seen from the figure that both of the maximum and minimum criterion line exhibit an inversely proportional relationship with the number of fatalities. In addition, it is also observed that the flammable risk line of this process plant has propagated over the maximum criterion line, meaning that it has exceeded the elapsed region. Therefore, it is crucial to implement mitigation methods to ensure that the flammable risk can be reduced to the acceptable level, which guarantees the safety of the factory workers as well as the residents in that area. Furthermore, it can be concluded that in the flammability risk, catastrophic rupture model exhibit a greater threat to the surroundings as compared to the short pipe rupture line with risk integral percentage of 99.95% and 0.05% respectively. Meanwhile, it can also be deduced from the potential loss life table that the operators possess the highest risk, which is due to the fact that they are working closely with the production plant. Next, admin exhibit the second highest risk because of the office located near the process plant. Lastly, it can be seen that the residents in the area has the lowest risk because of the residential area located further away from Yeocheong Steel Factory. However, the residential areas nearer to the plant might still be affected by the flammability risk. Last but not least, I will be discussing on the potential risk to the highly occupied area within the production plant. In the case of flammability risk, it can be summarized that the most affected personnel will be the operators due to their working environment, which followed by admins and the public due to the office and residential area locations. Moreover, it can be concluded that the impact towards the indoor environment will be more severe compared to the outdoor environment. Based on the individual and societal risk assessment, the overall risk of 0.15 annually is considered to be high, since a fatality risk of more than 2 fatalities per person each year is considered as unacceptable. To conclude, it can be summarized that the occupants of Jalan Sungai Pari will not be safe if there is any catastrophic events occurred to the Yeocheong Steel Factory. Besides that, The closest residential area to the Yoi Chong Steel Factory is Jalan Sungai Pari, which located only 500 meters away from the plant. If any accidents were to happen to the process plant, it can be summarized that the public will not be safe towards the flammability risk because the 500 meter distance is considered to be short, and the public located inside of the location-specific individual risk band stated earlier will all be affected.
To sum up, it can be concluded that both line rupture and catastrophic rupture of blast furnace has the risk of occurrence affecting the nearby residential areas. However, catastrophic rupture imposes a greater threat towards individuals and the society as compared to the line rupture. This can be proven from the comparison of risk integral percentage and average fatalities between line rupture and catastrophic rupture, where catastrophic rupture resulted in high percentage and value. Hence, it can be deduced that mitigative measures should be taken to minimize the risk. As the overpressure of blast furnace that leads to line rupture and catastrophic rupture can be caused by instantaneous boiling of water, the risk can be minimized by improving the water spraying method, in which the total amount of drawing water should be controlled. Secondly, automatic operation mode of relief valve, in which it can be opened in time to relieve pressure when overpressure occurs. Next, improve the materials and structure used in the blast furnace and its line. Lastly, strengthen the safety knowledge training of on-site operators so that the operators fully understand the abnormal conditions of the blast furnace.
In an integrated iron and steel industry IISI, wastewater generated from coke oven byproduct COBP plant is considered to be the most polluting stream. This wastewater contains toxic chemicals like phenol, cyanide, and ammonia, which are harmful to the receiving water bodies when discharged untreated. The coke oven byproduct plant, COBP plant, is an integral part of the byproduct coke making process. In the process of converting coal into coke using the byproduct coke oven, the volatile matter in the coal is vaporized and driven off. This is coke plant ammonia liquor, which is the treatment of ammonia produced by COBP plant. There are 3 stages of treatment in this liquor, which is primary, secondary, and tertiary treatment. The primary treatment, which is sedimentation and filtration, as well as steam stripping. First, the wastewater will go through tar removal via sedimentation and filtration with the addition of an organic coagulant. Then, it goes through the steam stripping of volatile ammonia followed by the pH adjustment with sodium hydroxide, stripping fixed ammonium, which often carried out in 2 stages in the same column. Stripping can also use free ammonium to blow down the gas scrubbing water closed system. The secondary treatment, which is activated sludge biological treatment. After passing through sedimentation and filtration and steam stripping, the wastewater then will pass through activated sludge biological treatment to remove BOD, phenols, and thiocyanate. A nitrification denitrification treatment is feasible subject to a few precautions that first need to be evaluated by testing, which is the absence of inhibitors. Then the wastewater will go to the tertiary treatment, which is the physical chemical treatment. This will be processed if necessary for residual colloidal COD reduction.
Next, I'll be explaining on the sustainability elements that considers the economic, social, and environmental aspect for the wastewater treatment plant. Sustainability can be defined as fulfilling the needs of present without compromising the ability of the future generation to meet their own needs while ensuring a balance between economic growth, environmental care, and social well-being. In economic sustainability, sustainable employment opportunities can be generated by motivating different investors in the wastewater treatment plant. This will create a vast variety of jobs that require a range of skills, knowledge, and experiences. Moreover, since most industrial facilities depend on water within their operation, lowering the cost of the water or recycling will lead to reducing the overall operation cost. In addition, the wastewater treatment facility has the ability to recycle value-added products such as crude proteins, which could be recovered from poultry wastewater through ultrafiltration, yielding reduction in the COD of the processed wastewater. In social sustainability, wastewater treatment plants hire people to work and thus secure job opportunities that can help in decreasing the number of unemployed workers. Moreover, the wastewater treatment plant could produce a high-quality fertilizer and lower its price, especially for the smallholder. This will lead to an increase in their income and their net profit. Through modern wastewater treatment plants, the risk of potential disease is lowered significantly. Overall, the livelihood of the local community is improved. In environmental sustainability, wastewater treatment is important to increase the clean water availability. Clean water is a requirement for societies and growth opportunities overall. In addition, the negative impacts on the marine life if minimized through efficient wastewater discharge. Treating wastewater becomes critical for life underwater as it has the potential for causing a long-term impact on not only the animals and plants, but also the human life related to it. One side effect of the wastewater treatment plant is increasing the odors, but in recent years, this effect was reduced significantly due to the extensive application of nanotechnology, which subsequently improved the air quality.
For regulation and standards in the steel industry, there are two regulations that conform to the steel and iron industry, which are Environmental Quality Clean Air Regulations 2014 and Environmental Quality Industrial Effluents Regulations 2009. This is the Environmental Quality Clean Air Regulations 2014. The regulations are applicable for the iron and steel industries. An iron and steel industry may require boilers, furnaces, or any fuel-burning equipment used for the purposes of heat generation. The gaseous emission limits from these facilities are stipulated in the third schedule of regulations under Item A, Heat and Power Generation, and Item B, Production and Processing of Ferrous Metals, Iron and Steel Mills. This is the third schedule under Item A, Heat and Power Generation, which consisted of boilers, combustion turbines, generator sets for combined heat and power production with a total thermal output more than equal to 3 megawatt. And this is the third schedule under Item B, Production and Processing of Ferrous Metals, Iron and Steel Mills, which consisted of the source, pollutant, limit value, and the monitoring. Next, Environmental Quality Industrial Effluents Regulations 2009. During operation of the iron and steel industry, an industrial effluent discharged from the facility shall need to comply these regulations. The following regulations are to be considered during the Environmental Impact Assessment EIA. Compliance with specifications of industrial effluent treatment system. Specifically, the treated industrial effluents quality from the premise shall comply with the 5th, 7th, 8th, and 9th schedules of the regulations. So, these are the schedules that have been mentioned before, which is the 5th, 7th, 8th, and 9th schedule of the regulations. The 5th schedule in the regulation that shows the acceptable conditions for discharge of industrial effluent or mixed effluent of standards A and B. The 7th schedule shows the acceptable conditions for discharge of industrial effluent containing chemical oxygen demand, COD, for specific trade or industry sector. The 8th schedule shows the acceptable condition for discharge of mixed effluent containing chemical oxygen demand, COD, and the 9th schedule shows the list of parameters for discharge of industrial effluent or mixed effluent which best management practice to be adopted.
Next, two significant air pollutants emitted from the metal manufacturing industries are carbon dioxide and sulfur oxide. Carbon dioxide is a colorless and odorless gas at atmospheric temperature and pressure. Under prolonged exposure to heat or fire, carbon dioxide may cause a container to rupture violently and rocket. Sulfur oxide is a colorless gas with a choking and suffocating odor. It is very toxic by inhalation and may irritate the eyes and mucous membrane. As the cause and effect of carbon dioxide. Carbon dioxide is formed through the production of coal and hot metal in blast furnace. To make steel, iron oxide is heated with carbon, while excess carbon reacts with oxygen to form carbon dioxide. The effects of carbon dioxide on human health are asphyxiation, headache, dizziness and nausea, increased heart rate, and elevated blood pressure level. The effects on environment include global warming and climate change, as well as formation of acid rain. Next is the cause and effect of sulfur oxide. Sulfur oxides originate mostly from sintering machines, coke ovens, and reheating furnace. The effect of sulfur oxide on human health are that it can harm human respiratory system, cause difficulty in breathing, and small particles from this substance may penetrate into the lungs, causing serious health problems. On the other hand, the effects of sulfur oxides on environment are that it can react with other compounds in the atmosphere to form small particles which contribute to particulate matter pollution. Moreover, sulfur oxide harms trees and plants by damaging foliage and decreasing growth, and last but not least, sulfur oxides interact with water, oxygen, and other chemicals in the atmosphere to form acid rain.